Hi, in this video we discuss LeetCode problem 1038 binary search tree to greater sum tree. So what is the statement? Statement is that given the root of a binary search tree, convert it to a greater tree such that every key of the original binary search tree is changed to the original key plus the sum of all the keys greater than the original key in binary search tree. So what is actually binary search tree first of all? What are the properties of binary search tree? Binary search tree is that whatever the root will be, we will have like this is our root. The left child should be always the less than the value of the root. It will be maximum 9. Okay, and in the right child of the root will be greater than 10, like at least 11, and maximum is infinity. Here actually maximum is 9 and minus infinity to 9. Got it? This is the binary search tree. So they have actually mentioned this also, like as a reminder, binary search tree is a tree that satisfies this condition. What is the condition? The left subtree of node contains only nodes with keys less than the node key, and the right subtree of node contains only nodes with keys greater than the nodes of the key. Okay, so all the value of like any node, we take any node, the left subtree value will be always less than the value of the root, this node, and all the value of right subtree will be always greater than this value root. Right, this is the properties actually binary search tree. Now what they are trying to actually, what they want actually from the binary search tree, like for this example, like this actually tree is 4 1 on observation. You can actually see the condition, like this is actually root. What actually I have explained that all the nodes in the left subtree will be always less than the 4, the root value. Here root value is 4, so here actually 1 0 2 3 all are less than 4, and all the right subtree value will be greater than this root value. Here actually 7 8 5 6 7 8 all values are greater than 4. Got it? How it's following the satisfying the condition of binary search tree. Or now what they want to convert this binary search to greater sum tree. What is actually this? So they want that the every node will be, the value of every node will be what the actual value currently those node will have, and also the plus the sum of all keys greater than the original key. So for this example, like for this 4, okay, so this will be 4 plus, what will be the plus value of all the nodes whose value is greater than 4. So what are those values? Like this actually 5 plus 6 plus 7 plus 8, right? This actually sum of actually 30. Got it? So any random node, suppose 7. So this will be 7 plus what? Is there any node whose value is greater than 7? Yes, 8. So this will actually 15. Got it? How it is getting 15? Now for this node 8, is there any node 8 plus which is greater than 8? No. So this will be 0. So ultimate value will be again 8. Got it? So for this 5, so what is actually ultimate 5 plus all node whose value is greater than 5? So this will be 6 plus 7 plus 8. These are actually greater than values. So this value will be 26. Got it? So now for binary search tree, we can actually observe one thing, like whenever we are taking any node, we are taking actually the right value. Got it? Got it? So what is actually happening here? So whenever we're taking anything node 6, we are taking, like actually for this 6 plus 7 plus 8, we are taking only the value of the right side. So what actually, and we already know what is the in-order traversal for a tree. In-order traversal. What is in-order traversal? Like for any node, like suppose x, this is y, this is z, this is this is a, this is b. So for in-order traversal, what will happen? First we will traverse the right subtree, then root, then we go to the left, right? So here actually first of all what actually you are doing, like for this value for any node like x, so what is the actually ultimate sum of, what is the value of this node actually, x plus a plus b plus z. So we have to actually first of all have to find out the what is the actual sum of the right subtree, right? This will be added to this current node x. Now we go to the y, then what will be the y value, ultimate value y plus this sum, this sum, like like first of all we're taking the right subtree value of the any root node. So then this will be added to this, because all of this node will be greater than this current root node value. So this will actually the root value for greater subtree. Now for we are going to left. Here what will happen? It will happen that all of these are actually greater than current y, because root will be always, because what actually left will be always less than the root value. Now all the on the right will be always greater than the root value, so ultimately this is actually all are greater than this y. So y will be x plus a plus b plus z. Got it? So in this actually we can actually do the inner traversal and take the sum. So let's go to the code actually. So we are taking a sum value which actually give us the what is the sum value of the right subtree. Okay, and this will be go to this parent node, right? And similarly for the left subtree also, right? So initially it will be 0 and we are calling the helper function. Okay, now if it is root node is actually null, then I do not have to anything return from that point. And what I have to do, I have to find out the sum of right subtree. That's why I'm calling the helper function and passing the right subtree, right child of the current node, and I'm passing the sum. And now there is, suppose there is no right subtree for this case, right child, there is no right child for this root. So suppose this is 10, it is 5. So what will be the actually value of this 10, and what will be the actual value of 15, right? Ultimate value. So what will, there is no right child, then what will happen? This will be recursive function will call and it will be returned because there will be null. Now what will happen? This value will be 10. 10 will be what? Sum is still it will be 0. So that's why 10 plus 0 it will be 10. Got it? That's why node value will be again 10. Now this will actually, I have to pass this to the left child, because this sum will be always added to the left child. That's why I'm also modifying the sum with the current node value. Got it? And calling the left child with the this current sum, which actually tell us the what is the total sum of the root plus right subtree. Got it? In this actually we can actually modifying the all node. Got the logic? Like we can actually take the example like 10, 2, this is 12, and this is suppose sorry, this will be 11 and this will be 13. Okay, so first of all I have to go to the rightmost child. So first of all right, this will be in this way, right, again right. Okay, and then it will be returned, right? It will be returned, right? There will be null. Now what will happen? I am modifying with the node value 13 plus sum is equal to still 0, so it will be again 13. Now sum is actually 13 now. Now what will happen? I modified this with 13 and now I will call the left child. It is null, so again it will be returned. See, I have already processed all the node. Now it will be go to the parent. Now parent, what will happen? 12 plus what is the sum value? 12 plus sum value is still 13. So this will be 25. Right? This will be modified to 25. Now sum I modified with 25 again. Now I go to the left child, right? Left child. So what is the value of this? 11. 11 plus what? sum value is 25 now, so this is actually 36. So I have also modified the 36 and I will call it this. So now there is no right child, so return from this, and this is to 36. Now there is no left child, also return from this, and after this return from this. Got it? Here actually sum is still 36 and here actually modified with 36. Alright. Now I go to this. Go to the parent. Parent will be 10. 10 plus what is the sum? Sum is actually 36. So what is the value? 46. This will be modified 46 and sum will also modified with 46. Right? Now go to the left because we already processed this node. Now go to the left. Node left. Now left will happen. I go to the rights. There is no right child, so this will be returned from this. Now this will what I will add 2 plus the current sum. Current sum is what? 46. So this will be 48. So this value will be 48. Now, and also I modified this 48. Now is there any left child? I will go, right, I will say there is no right child, a left child, so I will return back. And I have already processed this, so go to the parent. Now I have processed all the nodes, so ultimately you can actually check this value, like here actually 48. So 48 means all nodes will be greater than this 2. So 2 plus 10 plus this. Got it? You can actually check. So what is time loss of this? Like we are traversing each node only once. And space complexity, this is a time complexity. Any space complexity big of 1, we are not using anything, only we have taken only one sum variable. In this actually we are handling this, right? Thank you.